Hello everyone. Um, this is Sardam. In the previous video, I explained how to uh, how to define the function of Linux and the function of ex on the graphs, and I explained why ex is e to the power of x is the inverse function of Linux, and why Linux is also uh, inverse function of ex, vice versa. Um, Today, I'm going to explain the derivative and integration of each linx and ex. Let's start with ex. When we have ex, linx, yeah, oh, lin. When we have linx, lin of x, okay. How can we uh, find the derivative and integration of it? Let's start with the derivative. Um, for example, when we have ln of u, I replace it the x with u, but there's no change. When we try to find the derivative, it will be f prime equals to, we need to keep the u in the denominator, so it will be u, and then we will take the derivative of this one. So this is very important. This is the differentiation of ln u. Uh, yeah. For example, when you have an example, when we have um, ln of 2x, then it will be, we need to keep the 2x as u, because this is in the place of the u, so we need to keep it. Then we need to also take the integration of this, so the integration of 2x is 2, so it will be 2, so it is 1 over x. Okay. Another example is this. Uh, ln of ln x. So it will be, we need to keep this, so it will be ln x, and we know that this is u, and we know that ln x, the derivative of ln x is 1 over x. So the result would be 1 x ln x. So yeah, this is the derivative of ln x. So what is the derivative of ex? I am going to explain it. For the derivative of, don't save, yeah. When we try to take the derivative of ex, it is much more simpler. For example, when we have y equals to eu, the derivative of this is equal to, we need to keep this all, eu multiplied by the derivative of u. So this is the definition of it. Whenever you have any function of exponential function, when it is natural exponential function, we need to keep the original function, then we need to take the the derivative of the power. So this is it. For example, when you have for example, e to the power of 3x squared plus 2. Okay, we will do this. It will be e to the power of 3x squared plus 2. Then we need to take the derivative of this one. So it will be multiplied by 6x. That one is 0 and this is 6x. So it will be 6x e to the power of 3x squared plus 2. So this is an example. Another example is this. When you have this one, e to the power of square root of x, so it equals to e to the power of square root of x multiplied by the differentiation of this one. So we know that the differentiation of square root of x equals to x 1 over 2. So when we try to take it, it will be 1 over 2 x. We need to reduce it by 2 over 2. So it equals to minus 1 over 2. So it will be minus 1 over 2, which is equal to minus 1 2 root of x so it equals to minus 1 over 2 to the square root of x. No, not this. This is positive. Oh, how come I? Oh, it will be positive. I made a mistake. Yeah, this is it. So basically, this is the derivative of both ln x and ex. For the integration, it's almost the same. You need to do something else. Don't save. We don't want to save this. Okay. For the integration, for example, uh, I first need to explain something. For example, when you have the integration of this one, of ln x dx, it is never equal to 1 over x. It is a very great mistake because this does not equal to this one. You know, when we have the integration, but the correct one is that when we have the integration of 1 over x dx, so this one equals to ln x plus c. You need to be familiar with this because it might lead you to many more great mistakes. Most of the students think that the integration of ln x dx equals to 1 over x, but it is a great mistake. The integration of 1 over x dx equals to ln x plus c. So in this topic, we would think and we will consider this type of questions whenever we have 1 over x or 1 over u. The result of the integration would be ln u. So for now, we should ignore this part because it requires all the techniques of integration to be found. For example, when we have the integration of this 1 over x squared plus 1, and here we also have 2x dx. Okay, how can we find this? For this one, we can say that we have this at the denominator and we have dx. We can use u substitution to find the integration. For u substitution, we say what? We say u equals to this one, x squared plus 1. So du, when we take the derivative of this one, would be equal to 2x. The derivative of this is 2x. For this one, it is 0 dx. So we have the du. We need to replace this one with du and this all with du. So it will be yes, du over u. So, and for this one for sure we know that we have 1 over u. So it is 1 over u. We have du. So the integration of this one, we know it by definition, by this definition, that integration of this one equals to ln of u plus c, which is equal to ln of u is this one, x squared plus 1 plus c. So this is the result. Okay, there might be a question which is about this absolute value. Why should we keep and we have this absolute value? When we take the derivative of ln, for example, when we take the derivative of this of ln, for example, when we have ln x, the result of the derivation is 1 over x. Yeah, because I explained previously. Also, when we have ln of minus x, the result would also be the same. It will be 1 over x because it will be minus x over minus 1, because the derivative of ln minus x is, we need to keep this one at the denominator, and also then we need to take the derivative of this at the denominator, so it will be minus 1, so it will be 1 over x. So in both of the cases, if we have the minus or not, we will get the same result. So when we try to take the integration of this part and or this part, when we try to integrate them, dx, we don't know exactly which one is this. Is the ln of x has a minus or it doesn't have a minus? So for this, we will need to keep the absolute value of x, because we don't know exactly. If we put anything here, it will be positive or negative, because if we put minus and positive, we will get the same result. So if it is minus, it will 1 over x. It is positive, it will be 1 over x. So it means that we need to have an absolute value. So this property of ln x gives several properties of it. It gives this property of xy equals to what? Equals to ln x plus ln y. And also ln of x over y equals to ln x minus ln y. Also ln of x to the power of n. We will have n ln x. This is all about finding the integration of something that gives us the result of Linux. The most important part here is that we need to keep this absolute value, and also you need to know that when you have the integration of Linux dx, doesn't mean that it equals to 1 over x, because the other way around is correct only. When you have the integration of 1 over x dx, so we can say that it equals to the integration of it equals to the Linux in the absolute value plus c. This is about Linux, but what if we have um, what if we have ex? So when you have the integration of ex dx, the easiest procedure to be used here is that we need to use u substitution. For example, this one is our dx. So outside here, we need to have the derivative of this one, because um, all the way around we don't have we cannot take the integration of it. For example, we cannot have this ex to the square dx. We cannot simply, we can use it by using different techniques, but here we cannot use u substitution to find this, because we don't have an x outside, because the derivative of this is 2x, but we don't have any extra x here, so we cannot use u substitution here. But for this one we can use, because we say that our u is this x. Okay, our u is this x, so our du would be dx. So we need to replace them, so it will be eu du. I replaced the x with the u, and I also replaced the dx with the du. So I know for this one there is no difference between these two to work with, but there are much more complex examples that working with the u substitution is much more easier to work with the original function. So the integration of this one would be, the integration would be eu, because this is because when we have eu, for taking the derivative, it will always be eu, and also we need to have the derivative of u outside, which is du. So we have all of this, so it will be eu, because when you take the derivative of it again, you will get this one again. So I will replace it with eu, which is x, and also plus c. You don't need to put all of the focus on c, but it is very important to keep it, because most of the instructors take points when you don't write plus c. Okay, another example is this. For example, I want to put a harder example, I guess. Yeah, 1 over square root of x over the square root of x, then yeah, e to the square root of x dx. So when we have this, we should also think about the main step is using u substitution. So I say that my u is the square root of x. My du would be 1 over 2 square root of x. So this is my u of this dx. This is my u, and this is my, all of it is my du with this. So I replace it. So this is e to the power of u over du. There is nothing below, because it is all of it is du. It is my du, all of it. So it is easier to work with this one compared to this one. So we have this one. So we have it EU equals to EU, because when you take the derivative of EU, we will get this one. So when you try to go back to there, you will get the same. It equals to e to the power of x versus e to the power of the square root of x. I think this is a brave explanation of the integration and derivatives of both ex and ln x. Um, I hope you enjoyed the video, and um, I have planned to explain the integration and derivative of more examples about Linux, especially the integration of Linux. When you have Linux, how to find it through the U substitution. Also, in the following videos, I'm going to explain the integration and derivative of the exponential logarithmic function that the base is not e, so they are not natural. Um, yeah, see you there.